Officer, Department of Mathematics, SNS College of Technology. In this session, we are going to discuss about problems based on eigenvalues and the eigenvectors for the symmetric matrix. So, what is symmetric matrix? Symmetric matrix is nothing but by interchanging row and column means we get the same matrix now, that is known as symmetric matrix. Here, A equal to A transpose. A equal to A transpose. Here, given matrix A equal to 0, 1, 1, 1, 0, 1, 1, 1, 0. Here, interchanging row and column, we get the same matrix. So, this is symmetric matrix. Now, we are going to find the eigenvalues and the eigenvectors of this matrix. Okay, first of all, we should find the characteristic equation. So, characteristic equation of 3 by 3 matrix is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. So, s1 is nothing but sum of main diagonal elements. Here the main diagonal elements are 0. So, adding this we get 0. Next, x2 is nothing but sum of minus of main diagonal element. Already we discussed in last class. So, which value is equal to minus 3 here. Next, S3 is equal to determinant of A. So, determinant A value is 2 here. After that, the characteristic equation is lambda cube minus 3 lambda minus 2 equal to 0. Keep this as equation 1. Now, we are going to find the corresponding eigen values of this characteristic equation. So, putting lambda equal to 1 means the equation not equal to 0. Putting lambda equal to minus 1 means this equation will be 0. So, let it be lambda equal to minus 1 is the one of the root of this characteristic equation. By using synthetic division, minus 1 is the root. So, you are adding first element is 0 here, 1 plus 0, 1, 1 into minus 1, we get minus 1 here, 0 minus 1 minus 1. So, minus 1 into minus 1, we get plus 1 here. So, minus 3 plus 1 we get minus 2 here, minus 1 into minus 2 we get plus 2, which will be last values adding we get 0. So, now the characteristic equation factorized into one linear factor and quadratic factor. So, lambda plus 1 into lambda square minus lambda minus 2 equal to 0 here. After that, we find the solving this quadratic equation, we get the eigenvalues are minus 1 and 2 here. So, finally, the eigenvalues are minus 1, 2 here. This is repeated eigenvalues. So, for this concept, first of all, we should find the eigenvectors of the different eigenvalue. That means non-repeated eigenvalue, that is equal to 2 here. So, if we want to find the eigenvector means we should solve the equation, solve the matrix A minus lambda into x equal to 0. So, A minus lambda in matrix is in the given matrix diagonal elements are subtracted by lambda. So, we get this matrix 2. So, now lambda equal to 2 means the equation, that means the system 2 becomes minus 2, 1, 1, 1 minus 2, 1, 1, 1 minus 2 into x1, x2, x3 equal to 0. So, here we are having 3 equations, minus 2x1 plus x2 plus x3 equal to 0, x1 minus 2x2 plus x3 equal to 0, x1 plus x2 minus 2x3 equal to 0. Solving equation 1 and 2, we get the corresponding eigenvector. So, here we are using cross multiplication rule. So, considering the coefficient 1, 1, minus 2, 1, again we consider minus 2, 1, 1, minus 2. Now, which will become x1 divided by 1 into 1 minus of minus plus 1 plus 2, then x2 divided by 1 into 1 plus 2, then x3 divided by 4 minus 1. So, corresponding eigenvector will become 3, 3, 3. So, 3 is common for all the terms. So, corresponding eigenvector x1 will become 1, 1, 1. After that, putting lambda is equal to minus 1 in equation 2, we get 1, 1, 1, 1, 1, 1, 1, 1 is the coefficient matrix. Multiplying this, we get 3 equations 4, 5 and 6. These 3 equations are identical. So, consider any one of this equation. Now, I consider equation 4. Putting x1 equal to 0 means the Next eigenvector. So x1 equal to 0 means equation 4 will become x2 equal to minus 3. So now x2 value is equal to x1 0. In denominator of x2 we have 1. In denominator of x3 we have minus 1. So x2 will become 0 1 minus 1 here. After that, this is symmetric matrix. So given eigenvectors are orthogonal to each other. So let us consider x3 as element, and as x3 is orthogonal to x1 and x2, so it will become x1 into x3 transpose equal to 0. x2 into x3 transpose is equal to 0 here. So by substituting x1 and x3 transpose values, which will become two equations, equation 7 and 8 in terms of element. Here also we are using the cross multiplication rule. We get n divided by minus 2, n divided by 1 and n divided by 1. So corresponding eigenvector x3 is 2 minus 1 minus 1. Instead of writing minus 1 1 1, we can write it as 2 minus 1 minus 1. So now coming to the conclusion, the eigenvalues of A are 2 minus 1 minus 1, and the corresponding eigenvectors are 1 1 1, 0 1 minus 1, 2 minus 1 minus 1. Thank you.